There are 3 secondary amines that contain 4 carbon atoms per molecule. Draw the formulas. We're going to do skeletal formulas of the 3 secondary amines. It's sometimes easier to do the displayed formula first and then do the skeletal formula afterwards, but it's up to you. A secondary amine means that the nitrogen is bonded to 2 carbons. So if the nitrogen is bonded to 2 carbons, it must be in the middle of the chain. It can't be at the end, otherwise it would just be bonded to 1 carbon. So you're looking for a 4 carbon chain with a nitrogen in the middle of the chain. So what can it be? It could either be 1 carbon, 2 carbon, then the nitrogen, then the 3rd carbon, the 4th carbon, or the 1st carbon, and then the nitrogen, and then the 2nd carbon, 3rd carbon, 4 carbons. You can't have the nitrogen at the end, but there's another way of drawing it, with a carbon, and then a nitrogen, and then a carbon, and 2 methyl groups from it. You can either draw it like that, or you can put the H's on the ends, whichever way you want to draw it. Primary amines can be prepared from the reaction of halogenoalkanes with ammonia, or from the reduction, that means adding hydrogen to nitriles, probably with something like hydrogen with nickel. Justify the statement that it is better to prepare primary amines from nitriles rather than from halogenoalkanes. Well, when you react ammonia with a halogenoalkane, it'll make an amine, and then that amine can carry on reacting with more of the halogenoalkane to eventually make a quaternary ammonium salt. So with a halogenoalkane you can get further reaction, and you can say what's actually going to be made, a quaternary ammonium salt if you want to, but further reaction will get you the marks. Draw the structure of a primary amine with 4 carbon atoms that cannot be formed from a nitrile. So a nitrile has got a C to triple bond N. So if there's a C to triple bond N, it can't, then the C to triple bond N, once you reduce it and put the hydrogens on, it won't have 2 other carbons. So it's got to be a nitrogen bonded to a carbon with 2 other carbons, or a nitrogen bonded to a carbon with 3 other carbons. Neither of these could ever have had a C triple bond to an N, because that carbon would have had 1, 2, 3, 4, 5 bonds, and this one would have had 1, 2, 3, 4, 5, 6. So there's been a triple bond N there, a triple bond carbon to N there, and that couldn't have happened unless the carbon only had 1 other carbon bonded to it.